Today we're going to be talking about some unique improper integrals. I don't know if that's the right word for them, but some unique integrals that you might find on the AP. A lot of these are questions I think we're going to find in multiple choice. So in this first example, if the powers are the same, we can't split up this denominator amongst all of our terms. It's going to be really hard for us to do this. So if your powers are the same and you have a big polynomial on the top, polynomial on the bottom, or if your top polynomial's power is larger than the bottom, we can't use substitution, so we have to divide. So I have to divide and kind of reduce this polynomial. So x squared plus 1 into x squared plus x plus 1. So that goes in one time. 1 gets multiplied to the x squared. I don't have an x term, but I do have a 1 term. Now remember to subtract, those go away. I end up with an x here, that goes away. So we've reduced this. So this integral is now 1 plus x over x squared plus 1 dx. So taking the integral of the first term is x, taking the integral of this next term. This is a u substitution now, because your denominator, let's make our denominator our u. It's not inverse trig. If I didn't have this x on the top, it'd be inverse trig, but it's not. It's a u substitution. So our du is 2x. So I need a 2 there, a 1/2 on the outside. So then we have an x plus a 1/2 integral. All of this is my du over your u. Remember, the integral of 1 over u is the ln of your u plus c. My u is x squared plus 1. I guess technically I don't need those absolute value signs because x squared plus 1 is always positive, but let's put them in just in case. Okay, our next example, some of you might try and do a u substitution where you'd make the denominator your u. So then your du would be negative 2x dx. Well, I can easily add in a number, but I can never multiply a variable inside my integral symbol and outside my integral symbol. So this way doesn't work. And you might see over here, I have a little hint that it's an inverse trig. To me, maybe because I'm just used to it, it kind of looks like an inverse trig. It kind of looks like the derivative of inverse sine, which is 1 over the square root of 1 minus x squared. So if I could get this 4 to be a 1, I'm going to be golden. So what I'm going to do is underneath this radical, I'm going to factor out a 4. And simplifying that root 4, we get 2 square root of 1 minus, I need to change that x squared over 4 into something squared. It's kind of easy. Later examples are not going to be that easy. X over 2. Now make your u whatever in there. So x over 2. Rewriting that another way, remember that's 1/2 x. So your du is something really nice. 1/2 dx. So now we have the integral. My 1/2 dx is already in my integral. I have 1/2 times dx. This is my whole thing here. That's my du. This one's kind of nice. Later examples are not going to be as nice, and I kind of mentioned that in the video. So there's my du, square root of 1 minus u squared. Hey, look, that's our inverse sine. So this equals inverse sine of u, I got too excited, of u plus c. Don't forget your plus c. I forgot it in my examples earlier. But my u was x over 2, and we are done. So in this unique integral, this is what I might call a hidden inverse trig. This kind of looks like an inverse trig because I have a perfect square there. And I can't make any u substitutions. If I would try to make a u substitution, I would have the derivative, which would be 18x on top, and I don't have an x. And you can't multiply an x inside your integral and outside. So what we have to do is, with our inverse trig, this number needs to be a 1. So what I do is I factor out a 2. Remember, when you're factoring out numbers, it's like dividing each term by that number. Bring that 1/2 out in front. Now I need to make this 9x squared over 2 term into some perfect square. Well, that's going to be easy on the top, 3x. On the bottom, that's going to become a root 2. And what's in there becomes our u. Our u then is 3x over root 2. Then our du is 3 over root 2 dx. So I need to multiply by 3 over root 2 on the inside and root 2 over 3 on the outside. Now simplifying the outside, I get root 2 over 6. The integral, the numerator becomes my du. The denominator becomes 1 plus u squared. Hopefully you're going to recognize that as inverse tangent. It's going to be the inverse tangent of u. I'll fill that in a minute. Don't forget your plus c. I almost forgot my plus c in my notes. My u, again, remember, was 3x over root 2. Now this one's a little bit more complicated. It's going to be a hidden trig, but we have to do it completing the square too. So if we have a quadratic on the bottom and you don't have any x's in the numerator, you're going to have to use completing the square, and that's going to be challenging because I need to remember how to complete the square. So x squared minus 4x. Trying to decide which way I want to do this. I know the way I want to do it. Okay, remember to complete the square. You take 4 divided by 2 squared. So that's really 4. I'm going to break this 7 up into 4 plus 3. Because 4 plus 3 is 7. So now I've just broken it up so that I can factor part of that and get x minus 2 squared plus 3. I'm going to rewrite that for us so that it looks like the last problem where we have this. So this is now at our hidden inverse trig. Factor out whatever number is there so that you get a coefficient of 1. Now, going up here, again, the same trick as before. I'm going to bring the 1/3 out in front. One plus x minus 2 over root 3 squared. You guys just heard that ding? I don't know if you could hear that ding. I just got an email. Christmas break, January 2019. I got an email because that's harassing Mr. Boyle. And I got distracted by my email, so that's why I messed that up. Okay. Let your u be what's underneath the squared. Another way to look at that is 1 over root 3 times by x minus 2. So what is your du? Your du is just 1 over root 3 dx. So I need a 1 over root 3 multiplied by that root 3 there. So that means I have to adjust things. Root 3. Oh, that's going to bug me. Root 3 integral. Your numerator is your du. 1 plus u squared. So again, that's your inverse tangent. The inverse tangent often shows up on the EP. That's why I'm kind of stressing that. Inverse tangent of u plus c. Remember your u was this x minus 2 over root 3. So those were your unique integrals. Please make sure your Google form is filled out.